Okay, here we are. This is the last session for today. As we were doing so far, please write your questions if you have any in the track 2 in Slack. I'm gonna interrupt the speaker. That's what we've agreed before. So it's gonna be sort of a collaborative session. So please shoot your questions there. I'm gonna interrupt and ask the questions as we go. And with that, I think we can maybe get started. So Venkat, welcome. Thank you so much for getting the time for this session. So the stage is yours. Thank you.
Thank you so much. I really appreciate it. It's a great pleasure to be here to talk, and I want to say a big word of thanks to everyone who has taken time to join. Welcome on board. Best time to ask questions or make any comments is anytime you have a question or a comment. So don't hesitate. Please don't wait till the end. Fire away anytime, and I'll be delighted to answer your questions along the way. So let's get started. Well, I want to talk about the qualities of a highly effective architect. And I want to talk about a few other things, maybe a dozen things we can do as architects to be very effective. But let's start with the word architect to begin with, if you will. If I say the word architect, what comes to your mind when it comes to the vision of an architect? Maybe you were an architect, or you are an architect, or you aspire to be an architect. Well, I hope we don't aspire to be an architect like in the Matrix, right? That's not the kind of architect we really want to be in general. But the real type of architect we really want to be in general is the person who becomes a team player, the one who builds a team. I want to refer to this absolutely phenomenal article by Martin Fowler, which is called Who Needs an Architect? And I won't spoil the thrill of reading that article or rereading that article if you have already read it, but I want to mention a few things that he mentions in there. And one of the things is that he mentions the role of an architect. The article itself is focused on the architect and not the architecture, just like this talk is focused on architect and not the architecture. So I encourage you to reread it and again pass it on to other people on your teams. But I really want to aspire to be such an architect who is really interested in the team. So I'm going to talk about 12 qualities for an effective architect. Let's start really from the first one. The first one I want to mention here is be a mentor, not a tormentor. Now, we all take time to gain experience. Over the years, it's quite possible we may forget about the journeys we took, the young developer days that we took, or our growth into being an architect or other senior positions, team lead positions. But it's really important to keep in mind, one of the things we need to also do is not just focus on the architecture of the product or the application, but also developing the team and raising the bar as well. So nourishing the rest of the team is our professional responsibility. This reminds me of an experience I had. I was a consultant going from team to team, and one of the times I went back to a team after a few weeks being away, and a developer came to me with a list of questions, and I answered all the questions the developer had. At the end, the developer said, well, thanks for answering all of these. I had written these down, and I was waiting for you to come back to ask these questions. I said, well, I'm glad you asked these questions, and thanks for writing them down, but why did you have to wait for me to come back to answer the questions? Everything I answered, your architect could have answered. In fact, could have answered even better. Why didn't you just ask your architect? And the developer said, with about a surprise, you mean I should go ask the architect? Well, maybe you don't know, the developer said, almost every question the architect starts with the response, are you stupid? And then the response would follow. So we know, don't go talk to the architect. Well, that's kind of really sad, isn't it? Because being an architect on a team, if a person doesn't take the time to grow the team, how good is that really effective? In fact, you may say, okay, great, you want to grow the team, but what's in it for me? Well, I want to really emphasize, most of us are not in the business of charity. It's okay to be a little bit selfish. And so it's a really genuine question to ask, what is it in for you to really help the team really get better? And the answer to that question is, the knowledge is the only wealth I know that grows when given. If I give you $10, I may be poorer by $10. But if I share with you what I know, we both actually become rich on the knowledge portfolio. As I'm explaining things to you, you're learning, but you're also having that quizzical phase, and I begin to understand maybe I didn't really think about this deep enough, or I didn't understand it as much as I thought I understood it. I go back and learn more about it. Or you may ask a question or present a different perspective, and in the process, I end up learning as well. So we both end up learning when we really mentor each other, but a mentoring is a great way to learn as much as help somebody else learn as well. And that's one of the reasons we need to really do. So take the time to nourish the team. That's very important. The next thing I want to emphasize here is criticize ideas and not people. I know it's really hard sometimes, but we get into this mode of focusing on a particular topic, and then we throw words like, that's kind of silly, or I'm still really sorry that you thought about it, or why in the world would you even suggest something like this? Are you really, misguided like that? Well, the problem really is, without even knowing, we might start attacking the person rather than keeping the discussion and focus on the topic. So criticize ideas and not people. One of the key things to keep in mind is often there is no clear right or wrong. Both in life and programming, we can see that there's a lot of trade-off, and architecting is really evaluating trade-offs. And so we have to constantly evaluate trade-off, and what may appear to be really a good thought today may not really be a good idea tomorrow. So it's important really to encourage. So it's a better way to ask a question rather than saying somebody, that's silly, how stupid of you to suggest this, it won't meet concurrency. Instead, you could say, well, that's an interesting thought, but can you enlighten a little bit more about how we would work with concurrency with this particular proposed solution? And maybe they will give you three answers, right? One answer may be, well, here's how you do it. Hey, that's great. They thought about it, and you proposed a nice positive question. Or the answer is, gosh, I did not think about it. Let me get back to you, which is very reasonable. We want teams to work towards a solution. Or a third answer may be, gosh, I don't think we really need concurrency in this module, and maybe we can stand corrected that we were thinking about something that's not maybe relevant. So pose a question genuinely, encouraging the person to evaluate rather than trying to attack them for proposing ideas. Well, one technique we could really use is this technique called debating with knives. Of course, don't take real knives for this, but the idea is you sit around a dinner table, but you put the knives in the opposite direction between alternating people. If the knife is facing towards you, you favor for a concept. If it's facing away from you, you speak against that particular concept. And then you, of course, after a certain time, flip the knife and everybody else does so. And now you are speaking against something, or you would speak in favor of it, or vice versa. So it gives an opportunity for us to debate on both sides of an issue and to take the time to understand the pros and cons and be objective as well. So take the time to criticize ideas. That's very important, but without criticizing the people. One of the things I often do for this is I try to use the word we in conversation rather than you and I. And so we are emphasizing that this is a collaborative effort for us rather than trying to pinpoint and finger point at somebody. Well, the next thing I'm going to say here is to guide and don't dictate. When you work with a team of developers, in some companies and in some teams, we come to look up to the architect to give us all the answers. The problem with that approach is that there is a higher risk because an architect becomes a single point of failure if they are not making the right decisions, because we all get clouded by details oftentimes. You want somebody else to be able to verify that as well. So a command and control structure is not a good idea for a development team, unlike a military or an air force, for example. Secondly, as an architect, you want to really raise the bar of the team. You want team to be made up of professionals who are extremely good in working.
There is a question.
Oh, yes, please fire away.
Mentoring can take a lot of time. How to balance between deliverables and mentoring if time is short?
Oh, time is never short. It's our perception of time being short. I want to emphasize it. One of the key things we want to take the time to do is to prioritize what we want to do. If we are not prioritizing properly, we are going to deliver poor quality and spend more time later on fixing it. So time is never an issue. Lack of prioritization is the issue. So if time is really important, take the most important things to do and leave out the rest. And it always is a question of prioritization, never a time. We live in an industry, I want to say, which is misguided in this area. We think that we don't have time, but what we lack is a proper prioritization. We also are lacking quality quite a bit in what we do as well. And we end up spending more time fixing things in the later on stages. But instead, if we put priorities where it belongs, we're going to have a better life, both in programming and outside of it as well. So I would really encourage the teams to rethink about prioritization more than time itself.
Yeah, here is another one. Is becoming a team lead a prerequisite to becoming an architect?
Not at all. In fact, I would even argue that an architect to me is not even a title or a position. It is the responsibility one has. You know, I've served as an architect in many projects when I've never had a title of an architect at all, or a team leader for that matter. So not at all. You could be a team leader without being an architect. You could be an architect without being a team leader, or you could be an architect even without holding a title. So it's the responsibility rather than a position or a title for a lot of situations. And in a lot of companies that actually happens because the team is not really formally structured, but somebody takes on that role and then eventually, of course, becomes responsible to guide the team along. In a lot of ways, I would even argue a great architect is a great mentor who takes on the team under their wing. And as a foreman, I would want to say he's somebody who moves the team along. He or she is really responsible to just develop the team along with helping to develop the product itself. All right. And that kind of fits really nicely into the next point is we want to really raise the bar for the team, and we want to make the team effective in what they do. That is absolutely critical. And again, thanks for those questions, and I hope more to come along as we go on. I really appreciate that interaction. Be a guide and don't dictate. Now, I want to say when you work with a group of developers, you want to feel like you're working with intelligent and smart people. But that happens when they feel empowered to participate, and you are giving the opportunity for others to grow as well. So it's a two-way street. We need to facilitate and feel like we are being facilitated as well. But I'm going to say that there are two kinds of people that scare me the most. Those who cannot follow instructions and those who can only follow instructions. I'm sure you've worked with two categories of these before in your own experience. Those who cannot follow instructions, you tell them what to do and you come back and they have not done anything because they couldn't follow the instruction. More dangerous probably are the ones who take the instruction and follow it, end up with the wrong result, and you ask them, why did you do that? And they said, because your instruction said that. Well, they don't think about what is being given and apply in a context. So this really comes back to empowerment oftentimes, where a team feels like they're not empowered to really improvise and come up with ideas and suggestions. It's important to really be able to provide it. And one of the beautiful things of doing this is we may discover something from that experience as well. I'll give you one example of this. I had an amazing developer who came to me and said, I'm trying to solve this problem. How do I do it? And I discussed the problem a lot more with the developer. And then I said, now that we understand the context of what we are trying to do, I told the developer, I want you to go and figure out a solution, but don't spend too much time on it. Spend 30 minutes. In the end of 30 minutes, if you have an answer, that's great. If you don't, let me know, and I will tell you one way to do it. Please don't hesitate. 15 minutes later, I was walking down the corridor, the developer was approaching, and the developer looked at me and said, oh, by the way, thanks for that help and the advice and the recommendations. I went and investigated, and I was able to solve this problem already. I was able to find an answer with the context you provided me. And I said, that's awesome. What's the answer you found? What is the solution you're going to take? And the developer explains the solution. And I immediately said, I'm so happy I did not give you the answer, because what I had in mind is different, and what you have come up with is way better than what I had in my mind. I'm so happy you went and explored it. In this process, I already had an answer, but the developer came with something a lot better, and I ended up learning from this experience from that developer. So yes, I do have an answer most of the time, but I want to look for better answers, and motivating developers can help us to raise the bar not only of the team, but of ourselves as well along the way, and there's a really good reason to do it. In that front, I also want to emphasize to practice collective ownership. I'm a huge fan of this principle. I want anybody willing and able on a team to be able to modify the code and come up with ideas and design and improve it. I don't want really this very strict boundaries as to that's your job and that's your job. Anybody willing and able should be able to move things forward. Well, there is a term in our industry called the truck factor. Unfortunately, a truck factor is the number of people on a team that should be run over by a truck for the project to fail because nobody can maintain the code anymore. Unfortunately, the truck factor, as you know, in a lot of teams is a value of 1. If one developer quits, several modules of code cannot be maintained anymore. We definitely want to avoid that risk. So by collaboration, we have several benefits. Sure, if we start collaborating, we're going to be a bit slower in the beginning because we are taking more time to collaborate. But in the long run, our velocity increases because we are able to review each other's work, we support each other, we are able to maintain the code that each other wrote. We are also able to look for errors much more quickly as well. So even though the velocity may go down in the beginning, the velocity increases in the long run. And I have experience working with teams like that where we saw real evidence of that curve of a lower velocity, a little bit of time, and then an accelerated velocity along the way. And of course, creating readable code is extremely important. And one way I really know how to create readable code is to really have it read. So essentially, the more we read code written by each other, the more we make the code readable and reduce the risk in the code as well. So practice collective ownership. But also allow developers to figure it out. This is a little bit similar to guide, don't dictate, but a little bit step further beyond that to really give the time for developers to take their time to figure things out rather than being told exactly how to do things. But also when developers come up with ideas, how do we really promote those? That becomes extremely important. But one important characteristics we need to develop in a team as an architect and a team leader and just a member of a team is that making the environment really safe to be honest. Here's what we should never do. I shouldn't go over to a third person and say, you know what? I was talking to Joe and I'm shocked how little Joe actually knows. I don't know how they even hired Joe without knowing all this. Well, while I'm saying this to you, probably you're going to be thinking, interesting. If that's what Venkat says to me about Joe, I wonder what Venkat says about me to other people. Well, I've eroded your honesty. I don't have the integrity at this point. So I need to really represent good values and promote good habits and good thinking and good behavior. But I'll share with you one experience I will never forget. I was on a project where the project has been on for a few weeks. This was an expert in the industry that I was working with. I was so happy to be on this project. And about 2 weeks or 3 weeks into the project, I joined and I looked at the code that was there and I went to the team leader and said, who was leading the effort and the architecture and said, hey, there's a better way to really do this. And I'm looking at the code that's being done. I think if we go this route of design, things will be a lot better. I mean, he could have have said, why don't you shut up and go work on the code? We know what we are doing. Instead, he said, well, you think that's a better idea, huh? So how much time do you need to really figure out if that's the direction we should go? And I said, oh, I can do a quick prototype within an hour and come back and tell you. And he smiled at me and said, that's wonderful. Your clock just started. And he said, the time boxed interval has begun. I went to my desk absolutely eager because I was not struck down. I was given this opportunity to try this design idea. I started prototyping. 10 minutes later, I went back and said, hey, I've got an answer. And he said, well, that's pretty quick. I didn't expect you to come back this soon. What did you find? And I said, I found that I was stupid. The solution you had is much better than what I have. He said, no, I really want to know why you think that solution that you propose will not work, because I think that's actually a better solution if it's feasible to implement. And I gave reasons as to why that solution, even though appears really good at the beginning, has all these flaws that you begin to see the minute you start writing code. And I discussed the pros and cons. And the leader or the architect said, well, I'm glad you explored it. What do you think we should do now? And I said, we're going to continue with the code we already have in terms of the design. And I put everything I have behind it because I was convinced that that's a better solution now, in spite of the other ideas I had in the beginning. The point I want to emphasize is, but given that opportunity, I was empowered, I investigated, I proved that it was not a good idea, it might have been, and I threw everything I have behind the solution at this point, which is exactly what you want the team to do, is to be part of the solutions that you're working on with full belief in them. So when it comes to these, it's really important to provide a safe environment, but also to be able to proactively help developers to be able to discover things as well. And another example I'll say, and this tweet kind of corresponds to that morning I wrote it, I was working on a really hard problem, and I was struggling how to implement it. And I came across a blog post that explained how to do it. And the very first thought I said, oh my gosh, that's a different approach. That's a novel idea. How did I not think about it? That's fantastic. And then I said, no, I'm not going to use that in my code. I'm going to create a prototype for it. And I started creating the prototype. And within minutes, I found the flaws the article never mentioned. The author had said what's good about the approach, but failed to mention the pros and cons of it. And immediately I was able to see all the flaws in it. I had to abandon that approach and go back to design. And a few hours later, I had a solution. But that's when I tweeted this saying, funny how some good ideas go from being brilliant to stupid within minutes of prototyping. So I'm a huge fan of prototyping ideas. So time box your efforts and create a prototype. That's a great way to learn. And do that as an architect. Do this as a team and influence your team to build it as well. And so time box, give yourself whatever time you feel is right, an hour, 2 hours, half a day, depending on the complexity of what you're trying to do, and provide the duration for people to time box their effort and prototype and learn from the experience. But talking about prototype, I want to share with you another story and a learning that we can use, which is focus on the outcome, not on the process. This reminds me of an experience I would never forget. A company called me up and said that I need to come and teach their developers a certain technology. So I show up on the Monday morning in this remote city, and the manager said, I'm going to take you to the classroom, but before you go, I think you might want to talk to the people who are responsible for you to come in here. I said, I thought I came here because you invited me. And he said, no, I'm the one who organized the paperwork, but you're here because of these two people, and shows me into a dark room where two programmers are sitting and coding. And then he shared with me the story that developers had come to a conference, had heard me speak about a technology. They went back and realized how this technology can make a huge difference for what they are doing. They've been having a lot of trouble with the technology they were using. A lot of bugs, high maintenance cost, very difficult and time-consuming maintenance. So these developers, the two of them, spend the time prototyping and developed a solution, presented to the company and said, here is what we are doing now, here is what we can be doing, here are the pros, here are the cons, here's what you gain by staying, here's what you gain by switching, and here is the problem of switching as well. And they presented all these details with the code and said, evaluate. The team took time to evaluate, not based on hearsay or opinions, by looking at the prototype they had developed. So prototypes beats any argument you can make, and that's one of the best ways to really not only understand the technology, but also understand the ramifications of using a particular approach. This is one thing I cannot really emphasize enough. The best way to implement solutions and to learn along the way is to prototype. I really wish as an industry we spent more time prototyping and not converting those code into product, but prototype just to experiment, just to learn, just to illustrate, and just to evaluate different technology. That is highly critical for us to do as well along the way. So spend more time encouraging your team to prototype. If you're evaluating different technologies, divide your team into small groups and ask them to prototype different solutions and ask them to educate each other in evaluating the merits of each one, so we can collectively pick a solution that actually may make more sense. So we talked about quite a number of things already in terms of how we can influence a team and to be a better architect. But one of the things an architect also has to do is to gain the domain experience. I know probably you're thinking, oh my goodness, are you kidding me? There is so much we need to learn. We don't have time for those, we think. Now you're telling me I need to learn the domain as well. Well, we often fight the battle of, question?
Yeah, here is a question. Any tips on prototyping well? What are the boundaries?
The short answer is a prototype, first of all, should be isolated from the real code. Never prototype with your real code. And the reason for that is a prototype should really quickly expose the inner workings and the details you want to be able to get to without any constraints. And so create prototype in isolation and create prototypes very quickly. And I often like to create prototypes as a group or by pairing with somebody. And when you do create the prototype, put it out for the rest of the team to start over and take it and extend it further. So as you're discussing further with the prototype, oftentimes we come up with the what if questions. Prototypes are a lot easier to try those what ifs as well. But the key here is a prototype should be isolated, and a prototype should give you the insights that you're really trying to look for. Jot down questions you want answers for, and make sure the prototype gives you insights into those areas. And when you're done, leave the prototype away. You can leave that in a separate prototype directory, but don't copy and paste that code anytime. Then start with what you decide in production. I do prototyping not just to learn about what technology you adopt, but I also do prototyping to know even if a design is a good idea or consider trade-off between designs. So you really want the prototype to give you that insight that you're looking for by way of isolation and rapid prototyping, if you will. All right. So when it comes to the domain, we often think about extensibility. We all want to create extensible code. But there is one problem, though, we have to deal with. I think we can agree there are three kinds of people on every project. Those who know really well about software, but nothing about the domain. Those who know really about the domain, but nothing about the software. Those few who actually know both. I know what you're thinking. We'll politely ignore that fourth category in here. Well, these three groups of people, but the third one, those who know the software and the domain really well, are the one most capable of deciding about extensibility. You know, I used to work in the field of chemical engineering. I knew nothing about it. I would come up with all these extensibility ideas, my engineers would politely look at me and say, Venkat, we work with hydrocarbons. They would never behave like that, so you don't have to do it. Well, I'm so glad I asked that question because I can make it extensible from the software point of view. But what if the domain will never make that possible? That's unnecessary complexity and wasted code. So you cannot plan for extensibility without having the domain knowledge. If we don't have the domain knowledge, we got to collaborate with people who do have that knowledge, and that is basically how we can be effective. And over time, we have to really improve that domain knowledge as well. That makes us a lot more effective in our efforts to develop software. But not only that, one of the biggest challenges with what we do is learning is easier for a lot of us because that's what we do every day. But part of what we need to do is also to unlearn. And oftentimes we don't realize that we have to take time to unlearn. But unlearning, unlike learning, is very deliberate. Learning happens by way of the environment, but unlearning happens by way of behavioral change and deliberate critical thinking. But a lot of times we have difficulty learning, often because we haven't taken the time to unlearn something. So think about learning as a process where we have to replace some ideas, not just add on to what we already know, but that replacing ideas require the deliberate unlearning that we need to do. And this is one thing I've noticed with developers working in companies. They're really smart, but have difficulty because they don't realize they have to replace certain practices or unlearn along the way. So learning is relatively easy when compared to unlearning. Unlearning requires that extra effort we often have to put. So unlearning is a deliberate activity, and in almost every single practice, to start creating microservices, we got to unlearn some practices we've been following even without realizing when building monoliths or a service-oriented architecture. If we don't let go of those habits, it becomes hard to create what are truly microservices. Similarly, if you want to do test-driven development, you got to undo certain practices that let you create a design without really creating the test, and we got to put a deliberate effort towards doing those as well. But then, of course, we want to focus on diversifying our knowledge portfolio. The biggest risk we run into is knowing only one thing really well and not knowing a lot of other things. It's a reduction of risk, and making us a lot more versatile is to diversify our knowledge portfolio. With all respect, I will never call myself as put a name of a language blank programmer, a Java programmer, C# programmer, Python programmer, Ruby programmer, Kotlin programmer. Heck no, I don't want to call myself a language programmer, because a language, a programming language, or a framework, or a tool, or a library are exactly what these are. They are tools. Our job predominantly is problem solving. Our job is to understand the requirements and come up with solutions that are suitable for the problem to deliver value to our customers. If a language we do use is the right language, we should work towards it. But sometimes, if I find the languages I'm good at are not the right choice, I will step away and tell the team to go use something else and bring in the talent that's necessary to make that happen. It's extremely important that we use the right tool for the right job, not use the right tool that somebody is familiar with that may not be the right match for the job in general. But one way we can be effective in doing it is to diversify our knowledge portfolio. I need to really understand what are the different frameworks and libraries and languages, and what problem do they solve. I need to know that at a fairly high level and know a few things really, really well. I cannot know everything about something, but it's really important to diversify that knowledge so I know why different tools exist for different purpose. Remember, the pragmatic programmer said we should learn at least one new language each year. I think what they really meant was we need to learn one highly different language each year. You cannot say you know Java and you're going to learn C sharp and count it. No, C sharp is not different enough from Java, or Java is not different enough from C sharp. The language you learn, I would argue, is the one that allows you to kick and scream and cry out of frustration. What good is something we learn if it doesn't allow us to make us think differently? So I want to learn things that make me think differently, make me behave differently for the better, so that I can come back with more learning and more tools and evaluate what I could potentially use, but more important, how I can use what I am using differently. Let me emphasize that. One of the reasons I learn different languages is not that I would start programming in that language, but it helps me to rethink about how I design in the language I currently use. So when I start learning different languages, I become a different and a better programmer in the language I'm using already, rather than having to switch programming languages. This is one of the reasons why I really like to diversify my knowledge portfolio. I remember one experience. I was working for a team where we were writing C sharp code, and I was working with the developer when I said, hey, I've not done this in C sharp, but can we try an idea? And the developer was very receptive and said, yeah, let's go ahead and give it a try. And we wrote the code, and immediately, I'm not kidding with you, the developer literally stood up and said, oh my gosh, I've never seen code like that. The team leader came along, looked at what we were doing, and patted me in the back and said, hey, are you writing Ruby code in C sharp? And I laughed and said, yeah, exactly what I was thinking. And he said, that's pretty cool, and walked away. Well, the point really is, knowing how I did something in Ruby prompted me to develop a certain idea in C sharp, which is rather unconventional for C sharp programmers at the time, but gives you an opportunity to explore certain ideas in design that you may not have otherwise exposed to in a particular language. That's one of the reasons why I really like to diversify the knowledge portfolio. But also, I was teaching a group of developers, and I remember this day very clearly. In front of me in the classroom, there were two people, and I remember those two people right in the middle of the room, and they both had about the same number of years of experience. They both were older than me at the time. I think they still are. But those two people have the same number of years of experience. But one developer had diversified in multiple languages, the other one did not. And when I presented a new concept, it was interesting to see how they perceived it. The developer who were exposed to multiple languages would say, whoa, wait a minute, can you compare this to this other approach? Whereas the developer who has never been exposed would groan and say, why are we doing this? I was so happy programming in what I know. This hurts my head. I have to think differently. Well, that's when I tweeted this, and the tweet really said the amount of time you need to learn something new is inversely proportional to the number of different things you have learned in the past few years. So in the past few years, if you've learned only one thing, you're going to take more time to learn something different and new. But in the past few years, you've learned different things, then it's going to take a lot less time to learn something new. So one of the reasons you want to really learn continuously is not just to learn and broaden your knowledge, but to really keep your mental muscle active as well. And that helps a great deal in reducing the time to learn something new and makes you a lot more valuable for a team. After all, learning happens in deltas. So we keep learning in these increments along the way rather than learning a lot of stuff in a short amount of time. Our mind starts drawing these relationships constantly, and we keep building on our knowledge. So it's important to learn continuously and to diversify that knowledge as well. Well, as an architect, one of the key areas you can help a team is not to talk about what should be done, but to actually practice it. So lead by example. I'll mention this one experience I had, which I would never forget again. This was an architect for a company. And you can remember the architect's job is to promote the team towards better development practices, including the architecture. Well, I came to know this architect never writes automated test. Well, there is a requirement the team writes automated testing, but the architect never does. So expects the team to do, but doesn't have the experience doing it for himself. How could you lead a team if you never experience how to do that, and you expect them to do, but don't provide the support and the motivation to do it? So it's really important to lead by example. I would actually say architectural committee is where innovation goes to die, as I've seen in many companies. Because if the architects don't practice, you go with a great idea, they would readily kill it because it's not something they know how to do, and they really focus on, unfortunately, standardization. But standardization should not lead to stagnation. That's a very dangerous standardization. So in companies where there's a strong architectural committee, in a lot of them I've seen standardization that has led to stagnation. This is one of the reasons you need to alert people that they need to practice what they preach so they can jump in, roll their sleeves, and show how to do things as well. And also, a good architect practices what they preach. If an architect only preaches, that's very dangerous. They has to be able to really show the team how things can be done so that they can be the support for the team to practically implement things in the long run as well. Well, on the note of practicing, I highly encourage architects to write code. I have a name for architects who don't write code. I call them the PowerPoint architects. Avoid being a PowerPoint architect. Our job is to be able to write the code as well. I sometimes hear architects say, when I used to code back in time, well, that technology was obsolete and they don't know how to really make use of things that are current. So a good architect needs to really program with the team. You may say, oh, come on, wait a minute though, I don't have time for it. Well, you don't have to write code full time, but pair with developers a certain percentage of time every week. As an architect, if you're not able to control your calendar, you don't have the right priority, you don't have the right responsibility or the role. So you should be able to say 10% of my time, I'm going to pair with different developers to write code. Imagine how wonderful your experience is going to be at the level of the software. So when you make decisions architecturally, your decisions are more informed because you understand the plumbing and the wiring that goes into it, and you have a practical experience. So avoid being a PowerPoint architect. Realize that every technical decision has an expiration label on it. You know, if you work with architects who are making stale decisions, I give you an idea. Buy a can of milk, put that in the fridge for a month, don't open it. At the end of the month, take that gallon to work and you sit there. And as they are talking about decisions, take a cup and pour the milk. It doesn't flow. It makes noise, cluck, cluck, cluck. I know that sounds gross. And they stop and stare at you and say, what's that? And you say, that's a milk I put in the fridge a month ago. That's like the decisions we made 6 months ago, and we are sticking on to it. Or 2 years ago, and we are sticking on to it. Well, just like the milk in the fridge, technical decisions have an expiration label, and we have to come back and reevaluate it practically based on things that have changed over time. Finally, I want to emphasize it's extremely important as an architect to evolve architecture rather than be in a desire to jump in and build an architecture instantaneously. I know there's a pressure here. They hired you to architect. You better deliver an architecture. But a realistic notion is to emphasize and realize that we don't understand as much as we think we actually understood. So in the beginning, we don't understand a whole lot. So trying to really create an architecture when we don't have good understanding is a disaster in the making. So what do we do then? Do we tell the company, I won't create architecture? No, not at all. Create an architectural draft, create an architectural vision in the beginning, and then work with your team. And as your knowledge of your application increases, increase the level of confidence by bringing in details into the architectural vision. So evolve the architecture over the several sprints rather than trying to create it ahead of time. So take the time. So mention a percentage of confidence you have in the architecture when you get started, and say, hey, I have 10% confidence in the architecture, or 15%, 20%, but that's a collaborative understanding by the team. And they may say, when would you have more confidence? When we learn more, and here are the unknowns. We want to take the time to learn those unknowns, and when we know more, maybe prototyping, maybe discussion, maybe exploring, maybe trying to go investigate a certain technology or a tool, and when we have a better understanding of that as a team, we will come back and ratify our drafts and put more confidence into the architecture that we are creating. So the confidence in architecture should increase with the knowledge of the application. So the more knowledgeable we are, the more we should have confidence in the architecture. The less knowledgeable we are, we should put less confidence and more emphasis in saying we will create more, but when we start learning more along the way. So how do we really learn more, and how do we build such an architecture? Well, one technique we can use is a technique called the tracer bullet approach. What in the world is this approach? Well, this goes back to the notion that if you're trying to fire at a target, like maybe you are in a hunting or in a game, and if you're trying to hunt or fire at something, you may not really know where you're projecting. Well, a tracer bullet approach gives you an ability to visualize the trajectory the bullet takes, and with the power of the human brain and the feedback loop, we can alter where we are aiming. Well, the concept here in software development is that never to build an architecture in horizontal layers. Because if you build in a horizontal layer, you go far too much into one area, and the risk is exposed in other areas. Well, build in vertical slices, digging through the different architectural layers in your application. But as you come to a particular layer, if you're not ready to implement it fully, create a mock or a stub for that layer and keep that stub in place either until you realize you need that implementation and replace the stub with a real implementation, or you realize that was not actually necessary in spite of us thinking it is necessary, at which time remove that particular interface or that particular stub because you don't need that layer or that implementation you perceived as being necessary. So in other words, in a way, if you really think about it, if you're trying to organize a room, an office or a house, a room in a house, what do you normally do? You probably would create some little boxes which represent the size of things you want to place, and you place them and you try to look at it. You know, a couple of weeks ago, I was trying to design a particular closet, and my son was absolutely helpful. He created an AR, and I was able to actually see my design in the AR, and I was blown away. I said, thank you for doing this for me, because my ideas came to vision in front of me, and I was able to modify it right away and get a feel for how I want to look. Similarly, we can do things like 3D printing in the real world to be able to get a feel for, at a lower cost, what we're trying to build before we commit to it. Well, that's exactly what we should be doing in software. After all, software is more capable of lending itself for such efforts than other products. So create these prototypes, create these mocks, but build the application itself with these stubs and mocks, which eventually are replaced by real implementation or get thrown away if we really don't need them. And that is something can help us to really create this architecture by way of experimenting and improve the confidence that what we are building is going to actually hold true. And we remove the burden of late time discovery of problems. This can give exposure to problems sooner than later, if you will. So we talked about 12 different ways to be effective as an architect. Let's summarize and reiterate what we talked about. The first is be a mentor, not a tormentor. So it is our responsibility professionally to really be part of a team building, to raise the bar and help others become better as well. Criticize ideas, but not people. So you don't want to criticize people, you want to criticize ideas, but be very constructive. And also, you want to guide and not dictate as well. Practice collective ownership, allow for developers to figure things out, focus on the outcome, not on some process. Gain domain expertise along the way to be effective. Take the time to actively unlearn while you learn as well. Diversify your knowledge portfolio. Lead by example as a member of a team. Don't be a PowerPoint architect. Write code and evolve the architecture every step of the way using feedback mechanisms. Well, that's all I have. I see a raised hand. I'm happy to answer any questions for the next few minutes. And I really want to thank you for taking the time to be part of this event and for this talk as well. I really appreciate it. Thank you.
Thank you so much, Venkat. That was really a blast talk. I really enjoyed it. And of course, I've learned many new things here. There is a question. What are your thoughts on horizontal level architectures that are involved only during code review rather than the whole process of software development?
Well, when you say horizontal architecture, the code reviews has to be in different level depending on the insight you are trying to get from a code review. There are times I want only one function, one algorithm to be reviewed. There are times when I want a feature to be reviewed. There are times when I want a design review or even an architecture review. So I don't see review as a single thing we do. The purpose of a review is to give insight to what we are asking for. And a lot of times, discussions with the developers, we would have different kinds of reviews. And so depending on what we do, it might either scan different architectural boundaries or it might really not. It might be way too localized as well. So there's no one standard code review. The review should be based on what insight we are really seeking for that particular review.